Okay, we'll start from here. So what we were discussing about the for the case of cubic polynomial, how we can calculate this velocity at t equal to 16. So it is a very simple technique. We have already discussed how we can calculate it from linear interpolation, and this section is for the same with cubic polynomial interpolation. So we have discussed for cubic case we need 4 points. So let's consider that again. So if you are in your data we have 4 points like this. Okay, in linear case we are choosing, suppose this is at 16 15 and 20. So we'll consider this is at 15 and this is at 20. Okay, point. Now what we want is the point at for 16 we need to find out. Okay, so what will be the value of velocity at t equal to 16. So linear case we will be getting a line between these 2 points, and we know what is the point at this line when t equal to 16. That is the basic idea that we already find out. Now what we have to do in case of if you are having a quadratic polynomial, if you want to use quadratic interpolation, then we need to use at least 3 points for quadratic. So if this one, suppose this one is the nearest point after considering these 2 points, okay, then we can consider a quadratic case for this this case. Then we can I don't know exactly how it comes, but it will be like somehow like this, some small change if it is not linear. So you can have a quadratic interpolation also, and you can find out what is the value. It will be almost similar in this case because your points are very linear fashion. So but if you are having some different okay, let us consider some different. Suppose these are the 4 points and you are considering the quadratic spline, and for quadratic we need 3 points. Let's consider these 3 points for our interpolation, and then suppose this is at as we mentioned earlier, this is at 15, this is at 20, and I think this is okay, this should be at 22.1, right? Okay, I have considered this at 22.5. Now we can consider these three points and see how it will be different. Suppose if you want if you are looking for linear interpolation, we have this line which will be connecting these 2 points. We need only 2 points for linear interpolation. So then we can find out what is the value of this this will be your value corresponding to velocity for t equal to 16, okay, for linear case. But when you are using the quadratic case, when you are using quadratic case, then we have to consider 3 points, and your curve will be a little like this. Okay, it will be going like this. Okay, it will be like this. So in this case we can see that this when t is equal to 16, when t equal to 16 we have a little shifted point. There is a small shift in your y value or v value when t is at 16, okay, with quadratic interpolation. Similarly, if you consider for cubic case, then you have to consider 4 points. In that case we will be having different kind of plot. Let's say it will be going like this, okay, something like that. Then we will be having some different value for your velocity at v equal to 16. Okay, so in cubic case it will be it depends on how your points are. Okay, so it will be a different plot, and you will be getting a different value at t equal to 16, and other for all other t values also we will be having different values as compared to the other interpolation techniques. So this is basic idea. So for getting this cubic interpolation, to do this cubic interpolation, we have to solve this matrix and find out what is the value of v at t equal to 16. That is what we are doing here. And this is the basic idea behind the linear interpolation and polynomial interpolation with cubic quadratic. And if you are having, as I said earlier, if you are having 8 points, you can use a polynomial. With 7, you can use the same kind of polynomial interpolation. In that case, you have to fit all the 7 points with some particular polynomial, and you have to find out what is the coefficient. And if you know that coefficient correspond to, for example, it is you are having 8 points, then as I said earlier, we will be having a0 plus a1x plus a2 x square plus a3 x cube plus and a4 x raised to 4 plus a5 x raised to 5 plus a6 x. So in that case, you have to use this kind of polynomial if you are having 8 points, and you can use this kind of polynomial with up to 7th order, and you have to find out what are the coefficients a0, a1, a2, etc., all these coefficients, and then you can find out what is the, if you know what is a0, a1, a2, etc., all these coefficients, then you can substitute any value of x or t in this equation to find out the corresponding velocity at any point. So that is also possible. So this is the basic idea behind this polynomial interpolation with Python. We are using only NumPy, but if you are using SciPy, we have an additional function which is as you know, this sp dot interpolate interp 1d. That is the this is a special function for interpolation, so we don't need to calculate all these matrices, etc. It will already will be calculated in the program. There is one module which already have all these kind of steps, and it will give you result directly. So we just have to give the variables t and v, and that is the time and velocity data that is available, that you have to give as this array. Then you have to put here kind. Kind means what kind of interpolation you need. So here you can put in nearest neighbor interpolation, or you can use linear, you can use quadratic, you can use cubic. Okay, so all these interpolation technique you can use. You have to just put it in here as kind, then you will get that kind of interpolation. So you have to use this function sp.interpolate dot interp 1d and this syntax, then you can have this interpolation. But this is for this spline interpolation, and what you have to consider in the case of spline interpolation, there is some difference considered as compared to the normal interpolation. In spline interpolation, we will not take all the data points, but we will take adjacent data points, and we will fit we will use interpolation between all those points. So basically, if you are considering linear interpolation, it will take first these 2 points and take consider the linear interpolation between these two, and again it will take like this, then it will take like this. This is what it will do. Okay. Similarly, if you are taking a quadratic or cubic interpolation for this case, so it will be taking interpolation between like this. So first it will consider these 2 points, then it will consider this 2 points, then it will consider this 2 points, like this it will go. Okay. So this is the basic idea behind this spline. So it will consider 2 points at a time, and it will fit different interpolation, what we are cubic or quadratic type. Then it will be doing like this. So it is different from the polynomial interpolation. So if you are having any polynomial fitting for suppose 6 datas, then we will be having some kind of plot like this. But if you are using the case of spline interpolation with quadratic or cubic, then it will be fitting adjacent lines. So it will be going through like this. So there is a difference between polynomial fitting and spline like this. Okay.